inspiration to many members. Sir, I would like to welcome Sri Gurunadha Garu to keynote address.
Good morning to all. I welcome you all to the today's my presentation on emerging technology mechanical engineering journey of the power sector. I am working last 35 years in the power plant, so I felt that it is a good topic for me and suitable topic for me to deliver here because the energy sector. Am I audible? Uh, energy sector is the one of the important sector uh, which is fastly changing with technologies. Lot of developments are taking place. I hope you will enjoy this my presentation. My submission before starting, because this is the first time giving this type of presentation on this special occasion. That's why when I was invited, I felt happy that it's a great opportunity to meet the young engineers who are future engineer, future engineers, and if any doubt at any point of time, please ask me. My request is your kind attention. Thank you. Start with I told you now my presentation on the energy sector. So what are the first? I am starting from the beginning. How the energy sector from the independence now present. What is the how the journey of the power energy in total? Okay, the initially our conventional energy sources are coal, oil, and natural gases. Next, next, sir. Okay, we have good coal reserves. Our coal reserves are the 3,61,411 million tons. That is as on 2022. Production is 716. In that, non-coking is 152, coking is 57. So this total something not matching. Okay, this is import. Still we are importing because coal why we are importing the quality of our coal is not good. Or coal in Indian coals ash content is as a 40% as ash content. That means if you burn the 10 kg of the coal, you get the 4 kgs of ash, and the calorific value is also very less. So that is the big limitations for us. Whereas Australian coals, Indonesian coals, they have the high calorific value, their ash content is very less. And likewise, coking coal. The coking coal is the metallurgical coal that is used in the steel industry. So this is that we don't have the that coking coal. So we are 100% importing from the foreign countries. So with the present rate of consumption, it will last for 200 years. Coming to oil, oil reserves we have 587, and production is 30, and import is 171, consumption is 221. In last 40 years. See, oil is one of the main energy source for the uh, uh, for us, 40% of the oil requirement we are importing. So around we are spending a 90 billion dollars. So that is around 7 lakh crores of rupees we are spending on the import bill for just importing the oil. It is a that's why if you say in India not self reliant on the energy source point of view. So we are depending on the other countries. So that is the one big disadvantage to the India. So we are spending a lot of foreign currencies for importing the oil. Okay, sir. Next. No. So coming to natural gas, we have 40,000 billion cubic. The production is 1,333. Conversion is 1957. Import is 649. Around 37% we are of our consumption we are importing 30%. So this will last 65 years. So if you see the oil and natural gas, we don't have much reserves. So that's why we are judiciously we are producing. Though we have capacity to produce, we are judiciously because it has to we have to leave for next generations. That is called the sustainable development. Okay, sir. Next. So, as I said, presently oil accounts 30% Indian total energy consumption. India's production is 22 million against 110 million peak demand. So, natural gas also accounts 8.9% of the Indian total energy consumption. India's production 96 million. Okay, sir. So, just at the time of the independence, I just want to tell you what is the how the power sector. The power sector through the different conventional fossil fuels. These are the coal and the diesel and natural gas are the fossil fuels. Coal, we, at the time, total capacity was 1362 megawatt. Okay, and the diesel, our power generation was at that time coal, diesel, hydro, only three. Next, sir. So this is a typical coal-fired power plant. Just for your awareness, just I want to explain this one. This coal supply goes to boiler, where the coal will burn, give the thermal energy that will be taken out by the feed water supplied to the boiler. So steam will be produced. So that steam will be go to the turbine, steam turbine. So where the thermal energy will be connected to the mechanical energy, which is coupled with the generator. So electrical energy will be produced. So through switchyard it goes to the overhead lines. So this is the. So we take the in the turbine, the steam will be condensed. And that steam cooling will be done with the cooling water. Again, after cooling, the water becomes the feed water to the boiler. That is the closed circuit. What is the next slide, sir? This see how the boiler inside the combustion will take place. So the forced draft fans will supply the air. Will be taken by the water and becomes steam. Next slide, sir. Here you can see the combustion. Then the flue gas goes to the electrostatic precipitator. because the flue gas contains the ash that will be cleaned before it emitted to the atmosphere. So this electroprecipitator, when the flue gas passes through that ESP, there will be anode and cathode. The solid particles will be ionized, and the ionized particles will be entered to the cathode anode, and the collectors. So thereby dust particles will be collected. The clean air goes to the chimney. Okay, sir. So the basic thermodynamics feed heaters or incorporated to improve the efficiency. So this will heat the feed regeneration. Feed water will be reheated before going to the boiler. So that will improve the efficiency for another 5%. Next slide, sir. This is the improvement. This is the Rankine cycle. Keep on picture. So 1 to 2, that is isobaric heat addition. Isobaric means constant pressure heat addition done in the boiler. See that sir, you have pointer like pointer. Here to here, this is heat addition, feed water heat addition. A technomeasure, there is the sensible heat. The feed water temperature of the feed water ranges to the boiling point. Once it goes to that point, it will take the latent heat, and from there it goes to the super steam will be formed. There it becomes the superheated steam. By the time it reaches to the point 2, it will be superheated steam. From 2 to 3, we get from the 2 to 3 work done. Okay, 3 to 4. 3 to 4 is the isobaric heat rejection. It is done in the condenser. Again from the it will be steam will be in the vapor condition. It has to be in the condenser. It will be cooled and become the water. So by the point at the point number 4, the steam will become to the complete water phase. Phase will be changed from the steam phase to from vapor phase to liquid phase. So 4 to 1 is the isentropic compression, the air feed pump. So this is the closed cycle, complete closed cycle. So this simple Rankine cycle efficiency is very less, 35 to 40, 25 to 30, maximum 30. So further improvement done, next. To improve that one, this is boiler, what I done, that back sir. So this is the physical, as per the cycle, here 1 to 2 pump, 2 to 3 boiler, 3 to 4 turbine, where we get the work done, and 4 to 1 heat out. So condenser is the sink. If you see the boiler, 2 to 3 is the source. So here see 1 to 2, this 4 to 1. It is the place where we are to improve the Rankine cycle, regenerative heating on the boilers. So what will they be able to do? From the turbine, to take the extraction stream before it go to the exhaust to pressure, take tapping to from extraction in the middle, and that will be fed to the HP heaters, the heaters, HP heaters, LP heaters, different heaters. So through which the feed water will be preheated, and the load on the boiler will be come down. So by the time it reaches the feed water to the boiler, it will be preheated to saturation point. So the heat requirement for the steam will be come down. So thereby the efficiency of the cycle improves. So here it is. I think you can understand this is the cycle LP heater. So the condensate pump. So everything is self-explanatory. I hope you understand. If any doubt, please ask me. What's the next? So this is our typical thermal power plant boiler. Okay, in VS also same type of boiler is there. So that's why I brought this slide. So here the boiler firing zone where the coal will be burned. So that is the radiation zone. So the evaporation of the water will take place. Before that, it goes to the economizer. The feed water first comes to the economizer and goes to the drum. From drum, water comes to the firing zone. From the firing zone, it goes to the superator. There are three superators. One is a primary superator, and another is low temperature superator. Third is final superator. So this is the convection part. So this is the radiant zone. This is the convection part. This total area. So this is aerator. This is one more aerator. Two aerators. One is to preheat the primary air, and another is to preheat the forced draft air. The primary heater is for the primary is for carrying the coal to the boiler, and other forced draft air is the for burning the oxygen supply to the coal. So the flue gas. So coal will be burned at the firing zone, and flue gas travels to the latent, that is a PASH, latent superator, final superator, and the zones, and superator zone, then economic zone, then aerator zones, then goes to the ESP, different chimney. Okay. Then next slide. This is the steam turbine, typical steam turbine. It is coupled to the generator. It is on the general bearings. Here one there also one bearing, terminal bearing. It contains the number of stages depending on the design, the megawatt and the load and flow of the steam. You can see the control valve there through which the flow of steam will be regulated. Accordingly, you can vary the generation, and you can see the extraction control valves. So I told you now this extraction control valves, steam goes to the regenerative water heaters, feed heaters. Next. So this is the capacity of our turbine. It has one impulse, 37 reactions. So see, first just back side. Next, okay. This is the steam comes from the line, red line, thick red line is coming from the boiler. It goes to the ESP. That ESP means emergency stop valves, through which the steam will be admitted to the turbine. Before that, it passed to the first is the emergency stop valve, then the control valves. You see the 5 control valves are there. Then steam comes to the turbine. So see the turbine drawing. See here the specific volume is less. So as it passes, it expands. The specific volume increases. That's why it has been enlarged. The volume of the steam will increase. Next sir. Okay sir. Okay. So here you see the extractions. So different extraction for the, because the efficiency of the Rankine cycle is a limitation. Cannot beyond 35 we are not getting. So next generation is the combined cycle. So where the natural gas will be used, the gas turbine. So this is the typical flow diagram of the combined cycle power plant. So here the compressor and the gas turbine will be coupled. This turbine again coupled with the generator. Okay. So the air will be taken from the atmosphere, goes to the compressor. It will be compressed, and the compressed air and the natural gas both will be sent to the combustion chamber, where it will burn. The high temperature gas will come. That high temperature and pressure gas comes to the gas turbine. That goes to the gas turbine, where the gas will be expanded, gives the mechanical energy, and which is given to the generator. There the electrical power will get it. So the exhaust gases will have the high temperature. So that will be that heat will be required in the heat recovery steam generator. There water will be given. It contains the two cycles. One is the gas cycle, another is Rankine cycle. This is the Bapatla cycle. This is the Rankine cycle. Two cycles are there. That's why it is called combined cycle. So here feed water. It is again come to the like normal power plant. Only thing is here fuel will not be required. The hot gases is used to generate the steam. So it goes to the turbine and it is generator comes to the steam turbine. The power will come to the generator and to the both are connected to the. So you get two powers. One is Bapatla cycle, another is Rankine cycle. So the power generation is the efficiency, and here you get 40 to 45%. So there is a further improvement in the efficiency. Okay, sir. Next, this is the two cycles. I told you, one is gas cycle, another is steam cycle. So this is Bapatla, this is the Rankine cycle. So the efficiency will be around 45%. Okay, sir. Next. So the limitation of the combined cycle is only natural gas only used, but we don't have the much. Though efficiency is high, but we cannot produce the as much as we require. So we have importing the gas also. That is the one limitation with the combined cycle. And now coming to the this is the next version. Supercritical temperature, at a critical point, they operate at a critical point. So directly to the water steam phase or vapor phase. This there is no latent because the water phase and vapor phase exist the same temperature at the same pressure 221 bar. So it is a improved efficiency, and there is a reduced efficiency per megawatt. When you improvement of efficiency because the megawatt will be emissions of will be reduced. So low operating cost, high capacity power. Now all the most of the NTPC power plants and what are the new thermal plants coming on this supercritical and ultra critical power plants. So which uses the regenerative cycle and operates at the critical point because of higher efficiency. Next. So another aspect in the power sector. Waste heat recovery. Actually, I told you, energy is a very precious source because we don't have the energy, so we are still depending on the imports. So we should not lose any opportunity. And our aim is to high efficiency. So we have to improve the efficiency, and we have to reduce the wastages. On that, it is waste heat recovery systems technologies are come. In the waste heat recovery, the main objective is in the process power plants. There are certain areas the heat will be generated. Earlier, that is that is not entrapped. So this now we are recovering. Waste heat is recovering. So earlier that waste heat we used to lose to the atmosphere. So now the technologies have come to recovery that waste heat. For example, in our power plant, in our steel plant, so we produce the hard coke. So this is the chamber. We produce the hard coke at 800 degrees centigrade. So in the old steel plants, we have needed to cool that coke. Water quenching will be used to be done. Thereby, that is polluting the environment and losing the heat. So the next steel plant. So Bakoro Billa is the old steel plant. So there the water quenching is there. So when it comes to the 1980, our technology was 1980 based technology by the steel plant. So this was this technology was given, adopted. Not only this one, 3-4 other waste heat recovery systems also adopted in the later new plants. So here this hard coke at 80 degrees will be charged to the chamber. The heat will be taken by the mill fan. Air will be supplied. So the outcoming gas, hot gases will go to it is like a heat exchanger. So here also come a boiler and evaporator and separator there. Steam will be produced. That will be used to the power generation. So next slide. So this is we have back pressure turbine. Here this 40 steam we are getting. And that will be used to produce the electric power. In this turbine, here I have given why I am showing this slide. So far, whatever you see in that condenser type turbine. Here, this is the extraction. Two extractions are there. This will be used again in the process. Okay, next slide. So this is with this waste recovery, we are getting the 43 megawatt. Okay, it is a good amount we are using. We are getting without any input of fuel. We are getting 43 megawatt with a little investment. So it is a great opportunity. It is a good technology adapted at that time. And this is another this thing also, same thing. Here we get the hot sinter. So that will be sent on this bed. From the bottom air will be given. That will be sent to the boiler. Again you get the energy. Next slide. So this is how the drum that it will feed to the air. And these are the fans supply the air. Okay, sir. So here we are getting the 90.2 megawatts. Okay, next sir. So here we are getting 38 megawatt. So like this rolling we will operate cooling system is there. Next sir. So we have the BF gas, using BF gas we are generating around 120 megawatt. So with all these units we are getting around 200 megawatt. A good amount of power we are getting. So that is one part. Now coming to the environmental problems. So when you burn the coal, you will get the 1.5 ton of for 1 ton of coal you get the 1.5 ton of CO2. This is the problem with the main thermal power plants, coal-based power plants. So they leads to the air pollution and climate change, that is global warming, water pollution, thermal pollution, solid waste disposal. Solid waste disposal, I told you the beginning of coals are having the high gas content. So lot of waste disposal system you should have to store that whatever the ash coming to the power plant. Almost you are getting the of the coal of the ash and the coal. Okay, this is the CO2 emissions. If you see the graph, coal fiber producing the more emissions, CO2 emissions. Now the thrust is to reduce the CO2 emissions. So now the time has come because of the environmental change. Now global war, because of the global warming, so the pollution CO2, the now the norms has come to reduce the CO2 emissions. On that there is two policies. One is the energy policy and the Conservation Act 2001. These two has come to address these two problems. So this is under energy policy, Congress established a legal requirement for all the federal agencies to derive the 5% of their electricity consumption from the renewable resources between 2010 to 2012, rising 7.5 thereafter. So you have to slowly reduce the CO2 emissions. India is committed to reduce the CO2 emission intensity 33% to 35% in 2030 compared to 2005 level. So government announced 100% railway electrification by 2030. Country project to reach the net zero emissions by 2070. But before that also we are trying to achieve this one and decarbonizing the power. Why decarbonizing? Because carbon only the main culprit. When you burn the coal, you get the CO2. So you have to avoid the carbon usage. So decarbonizing means the reduction of the carbon usage. So pathway of facing down the coal in power generation to reduce the CO2 emission, reduce carbon is what I said. That for that fossil fuels you have to substitute with the clean energy. So on that direction, Energy Conservation Act also come 2001. One is to achieve the zero emissions and renewable energy sector. So actually the importance of the renewable energy has got the momentum because you have got a limitation to use the coal. So the power generation to the renewable has to be further to be augmented. Okay, sir. Next slide. So renewable energy, these are the different energies: solar, wind, hydro, tidal, geothermal, biomass. Among these, solar and wind got the momentum because of the technical feasibility and availability. The power generation through the solar energy and wind energy increase. So the advantage is the green energy. So no carbon emissions, no fuel cost. You don't require any fuel. The solar panels at low cost now available. Earlier the PV panels or photovoltaic panels were costly. Now due to mass production and government incentives also given. So that making the solar panels at lower cost so can be installed anywhere. So it is not place is not required. You see the many canals over the head canals and unused land there you can install this one. And the main limitation is the weather. They are the weather dependent. and the weather dependent, because of the weather, what happen, daytime only get the power, night time no power. So the plant load factor will be very less, it is less than 20. So that is a one limitation, and another is power charge is intermittent. So daytime you get, night you don't get. So solar, so suppose you cannot, okay, you will store it and use. That is also not possible. Storage energy is expensive, needs a lot of space. Okay, next, wind energy. Coming to the wind energy, also same. Green energy. It is also green energy, carbon emissions, reduce carbon emissions, no fuel cost. It can be installed remote areas where wind velocity is good. Wind is almost available everywhere. The limitations is it is also same thing, intermittent, high noise. Ideal wind sites are often remote. Wind velocity should be good enough to install it. That is one limitation, but still, okay, lot of power plants are locations found in India where wind energy can be produced, especially Tamil Nadu, lot of windmills has come. Threat to the wildlife, another limitation. So with this, see the coal power, how the coal power generation is coming down, how the solar and wind has raised the generation. So you can better understand from this slide, next slide. This is the fuel mix. See, in 2010, most of the energy will be coal, fossil. The energy we need to get from the fossil fuels. Now that is slowly that their portion is coming down because we want to reduce it slowly. By 2030, see 50-50. Maybe by 2050, no, 90% of energy will be generated from the renewable energy. Next slide, sir. This is the, so I told you already, low plant factor and fluctuation energy storage. This is the main disadvantage with this type of power energy, renewable energy. Okay. To address to some extent, this pumped hydro storage system has come. This what we will do, next slide we will go, sir. See, at low loads, what they will do, this generator will motor generate. It has two modes. So at low loads, what we will do, it will pump from the low reservoir to high reservoir, where the power is less and the power demand is less. That time, the power, it will be pumped to the reserve during the peak hours. So evening hours, night. So what you need power. So that time the water will be sent to the generator. Their power will be produced. So this is one type of technology available to bridge that demand supply gap. Okay, sir. This is energy conservation. Coming to the energy conservation, which I told earlier. This act is made to promote the efficient use of energy. So always you have to improve the efficiency because when your resources are limited, so the only way is produce more is the improving the your efficiency. Further, the government of India made energy conservation act. On that, the main object is to promote the efficient use of energy, and it provides the legal work framework, institutional arrangement, and a regulatory mechanism, establishment and incorporation of Bureau of Energy Efficiency, and create a suitable environment for demand of energy products. Okay, sir? So this is established 2002 to reduce the energy industry, quasi-regulatory body developing policies. On that, different schemes are there. One is the STAR label, Standards and Labeling Program, Energy Conservation Building Efforts, and Perform Achievement Trade Certificate, and Energy Audits. Thereby, these schemes energy efficiency will improve. So the star level, the main is the evolve the minimum energy consumption and performance for the notified equipment appliance. So this will understand you whether how much it is consuming. This type of label must be observed in the recent home appliance is coming. So what is the energy for consumption per hour and per year, so that you can select it. And it creates the awareness among the public also. Next slide, sir. Here you see CAT, this comes to the industry level. Suppose for process, certain amount of energy to be used, minimum energy. Suppose if you are using the more energy, so it should be reduced. So if you are producing at a lower energy level, so you will be given the this certificates, perform, achieve and trade certificate. This is motivational certificates. Back side. This can be you can sell at power exchanges. So one type of motivation. So if any industry is producing at a lower energy than the present requirement, so they will be encouraged to do the make at a lower specific energy consumption. So now coming to the hydrogen is the future energy. So I told you now earlier we have one limitation because of the in the renewable energies we cannot store the power. So this problem is addressed in the hydrogen. This is the latest development in the energy sector. You might have heard. It is also clean green source of energy. It can be produced from natural gases, nuclear power, biomass, renewable like solar and wind, other sources. So today hydrogen fuel can be produced to the several methods. Okay, go to the next slide. So this is produced through two processes. One is electric and so electric process, the electrolysis. So what will be electrolysis process? H2O can be divided into hydrogen and oxygen. So electricity usually here the renewable energy. So next slide. So main advantage of the hydrogen is see the energy carrier. So here with the what are the limitations we are having the renewable energies that has been upset here. So it can be stored and moved to the other place and it can be delivered to where the requirement is there. And it is a clean fuel, consumed fuel cells, only water emissions. Here no CO2 emissions. So many advantages. You see how many advantages are there. And these two make the hydrogen the future energy. Okay, sir. Next. So this national hydrogen mission to motivate that one. So national hydrogen mission was formed, is launched by our Prime Minister Narendra Modi 2021. So it is to promote to hydrogen as a clean and renewable source in the country. To aims to provide a comprehensive action plan. So by 2070, I showed net zero emissions. The idea, with the objective. Okay, next. So this is the I told the objective is export the green hydrogen. Actually, India has a very ambitious plan because we are export. So far, we are exporting the. We are importing the energy. 40% of our energy requirements we are importing. Now what we are saying, not only starting with imports, we want to export by generating the hydrogen fuel cells. So back sir, not. So reduce dependence. This will reduce our dependence on the fossil fuels. And become market leadership. Okay, these are the we want to do in the future. So this is the first pure hydrogen plant commissioned in the job, where using the this thing solar power 500 100 kilowatt power plant. So using the renewable energy, hydrogen producer. Next, this is the another blending project. NTPC recently commissioned first blending project. Next, sir. This is the animation. Next. So see the growth of the installed capacities. You see here earlier days the thermal energy produced. There is no gas, nuclear, and so later on they joined gas. Then it comes to the 97. This renewable energy started producing. So the share of the from the fossil fuels, thermal fuel to the renewable energy is increasing. That you can see that from that slide. So present we have the energy power generation through different sources. So 1,71,000 megawatt, 1,71,700 is the from the non-fossil fuels, and from the fossil fuels.
Okay. 236. 236.
This is 2 lakh. This is so almost we are producing the 40% of the energy from the non-fossil fuels. So earlier we used to generate 80% through the fossil fuels. Okay, sir, next slide. With that, so I think I don't know how to understand. What was the presenter? One small video, please, sir. Beautiful video recently I got regarding our future energy hydrogen. It takes only I think 3-4 minutes. So, do you have any doubts, questions? Did you understand my presentation? Either you understand well or you didn't understand.
These numericals are new, sir. They can learn, sir.
Yes. Why I provided these numericals to understand you the for awareness this thing.
Yes, sir.
So that's why I tried to show in the first stage because the numericals it is difficult to remember how the power sector evaluation. Because,
but statistics is required, sir. Without point of view, no, but that statistics is required to know.
Yes. So I kept figures also on that. Later on, so we can. This is regarding the hydrogen. Sound.
We are reimagining our entire energy platform. We target to become net carbon zero by the year 2035.
The green energy journey is truly underway. We are reimagining our entire energy platform by integrating solar, hydrogen and battery ecosystems. It's now time to kickstart the hydrogen revolution. We are creating India's first integrated end-to-end hydrogen ecosystem. The journey will start with green hydrogen production in our state-of-the-art plants. The hydrogen will then be stored and distributed through our extensive hydrogen retail network. As the first step in this remarkable journey, Reliance is proud to introduce Made in India Hydrogen Internal Combustion Engine technology for heavy-duty trucks. A unique and affordable solution for India. These vehicles are being developed with world-class technology partnerships. Powered by this hydrogen technology, we are set to redefine the future of green mobility. Reliance will induct these vehicles into its fleet in line with the net carbon zero vision for 2035. With this, Reliance is leading the transformation towards a greener future for all of us.
This is the Atmanirbhar. So India's self-reliance is will improve. Already Reliance has entered in the hydrogen field. So they, as per their plan, it is net zero emissions by 2035. Actually, I told you that 2050. So once this this is in the early stage. Once this technology develops, so there is a lot of scope. It is a good, what do you say, that big hope, a big ray of hope in the energy sector. Okay, sir. Thank you.
Thank you, sir. Thank you for nice presentation. What is present India is going on in the energy sector, and at the same time in the future also how we are converted into a green energy system. Thank you, sir. Thank you very much for your nice presentation.
I didn't get any questions. It is gone.
Now hand over to the.
No, at least tell me.
Any doubts?
Understand and did you appreciate our efforts?
Yes.
Any participants?
And give the feedback, honest feedback.
Rupesh, come forward. Come forward. Come. Yours. Okay. Your
Public speaking has to improve. Don't feel shy.
Thank you very much, sir, for an excellent presentation. I think if that is the scenario that in future we are going to convert from fossil fuels to solar and other green energy systems. And I think we need to improve the education sector also. I think we have CPRI, Central Power Research Institute, which is somewhere in Delhi. And I think such new institutes should come at every state capital, or CPRI institutes in Hyderabad, Bangalore, Chennai, and even such power research and power sector scenario need to be improved in education sector also. That's what I feel.
Compared to now, there are many power training institutes have come. Lot of now power petroleum institutes and a lot of R&D. All this are coming, and main nowadays the private participation also there. So these developments are taking very fast. See how the Reliance captured that opportunity. He will definitely capture it. He will make it. Already is in the energy sector, hydrocarbon field. So it is a big opportunity. And a new business altogether. Definitely India will go to the next orbit. Once our dependence on the oil comes down, India get a lot of it gets the big breathe. See, 40% for energy requirements we are importing. So that much money will be surplus to us. So once this technology success, I hope definitely this will come in a big way. And NTPC also, they are also this hydrogen technology, they are hydrogen fuel cells, they are also planning to. Definitely future, as I put on thing on my slide, hydrogen is the future energy.
Sir, good morning, sir. In one of your slides, you have shown that so from the coal-based plants, we are getting most of the CO2 emissions, right? Is there any other alternate other than renewable energy sources to generate electricity, right, without carbon?
Renewable energy not uses the carbon. No?
Yeah, other than renewable energy, is there any other mode of generating electricity? Right, other than
Other renewable, I told biomass is there. Still biomass also not done in detail. Biomass, through biomass also a lot of generation take place, because in agriculture you get the biomass.
Yes, sir, crop residues.
So that through biomass also we are getting the energy, but you have to see the commercialization.
Okay.
So what is the amount of energy available? So see, India is the good solar radiance.
Yes, sir.
So it is easy to capture everywhere. And so if you take the wind, wind is not that much.
Yes.
Because where the wind velocity is good, there only. Like us, this thing, there are some advantages and disadvantages.
Sir, other
Biomass is the limitation is the availability of the biomass.
Yes, sir.
Limited. Every year the energy requirement at the rate of 10% is increasing. Like GDP, the requirement increase. So you have to cope up that requirement. So you see, recent you might have observed the supply and demand.
Yes, sir.
So there was a gap of 4 to 8%.
Yes, sir.
10 years back.
Okay.
That gap now come down to 1 to 2%.
Yes, sir.
Because of this presence of the renewable energy. So once the renewable energy has come, the India's position become little better.
Okay. Right.
So the whatever the renewable is having the limitations, because it cannot be stored, it is intermittent.
Yes, sir.
These two problems can be upset with the hydrogen.
Yes, sir.
You can store the energy, you can carry wherever you require. That is the advantage of the hydrogen.
Okay. Thank you, sir. Thank you.
Any participant from online?
Participants from online can also ask questions. Anyone from online participant?
Good morning, sir. I have a small doubt. In the future, we will.
I have a problem.
In the future, you are running out of fuels. So you are going for the hydrogen fuel. So it is very expensive. So how can we afford?
That's what I'm saying. Now it is expensive. In the future, developments, that cost will be due to further developments. That's what I'm saying. This is the hydrogen energy still in a development stage, not commercially not yet started. Only fuels are now. Reliance has started. Just I shown the video. Commercialization it takes some time. Still developments are a lot of developments are have to take, and the main though it is expensive, but we have that solar the energy the power you are getting through the solar that is used. So once that is used, so the cost of the hydrogen will be come down. Daytime you are getting the solar energy, renewable energy, so that you are not able to store it. But whereas whatever the surplus solar, or you use it for the electrolysis process, produce the hydrogen and keep it available. So thereby the usage of the hydrogen will improve. Understand? There are two processes. One is thermal process, another is electrolysis process. So thermal process may be little costlier, expensive, but in the electrolysis process, so where the through hydrogen can be produced from the water, so only that require the power. If you get the cheap power from the renewable energies, so the hydrogen cost will come down automatically.
But in the Canada, the Toyota company already introduced the fuel cell electrical vehicles, sir. In the Canada,
In
Canada,
Canada,
Toyota company already introduced fuel cell electrical vehicles, sir. On the base of hydrogen fuel, they have already placed the hydrogen fuel stations.
So Canada, you don't have the solar energy. So what they will do, they will import the hydrogen. So there they will take. Why the compulsion is, another compulsion for hydrogen is emissions, zero emissions. Suppose if you use the oil, so emissions will be high. So that also making, actually the CO2 emissions normal, you see compared to India, developing countries more, 3 times, 4 times. They are forced to reduce the emissions. In that scenario, they will use the hydrogen. Understand? It is not the cost, it is a compulsion sometimes. So Canada is a rich country, they refer to it because power that emissions at the power plant they cannot reduce altogether. So in the whatever the areas they can reduce, they reduce through hydrogen. Okay, I think your doubt is clear. Okay.
Just once in online, he has raised the hand.
Sir, recently 5.9 million tons of
Online. Yes, sir.
Sir, can I talk now, sir?
Yes.
I hope I'm audible enough, sir. Good morning to everybody in the panel, sir. So this is my question. Sir, you might have known that recently there has been a huge discovery in Jammu and Kashmir, where we discovered, our Indian government discovered that there has been a huge amount of lithium ion which has been discovered in Jammu and Kashmir region, sir. So as we all know, lithium is one of the key ingredient, a key material which is used for lithium ion batteries, sir. So my question to you is that, sir, can this discovery affect our utilization of electrical vehicles? Can this boost the utilization of electrical vehicles, which our government has been aiming since the last few years, sir? So can this discovery help us create more electronic vehicles?
To electrical vehicles, recently in Jammu and Kashmir, there are reserves found. Lithium reserves. Lithium reserves are found in Jammu and Kashmir, sir. What he is asking is, will this change the usage of electrical vehicles? Because electrical vehicles requires batteries, which are based on lithium. That's what he is asking, sir. Will it improve or will it affect? In what way it is going to affect?
No, that is altogether different area. So this is come to the automobile. So we are slowly that automobile, the road pollution. We have to reduce the road pollution. We have to use the electrical vehicle. That's why the government given a lot of incentives. So this will not at all affect. So there comes there one point of time comes electrical vehicle versus hydrogen vehicle. So there now we cannot say, because tomorrow if your technology comes, so you can produce hydrogen at a lesser rate, they are giving better this thing. So obviously the hydrogen fuel will take over. But right now, the electrical vehicles with the lithium-based batteries, it is going good growth. So definitely both will go parallel.
Yes. Just any other part? Same question. Any more? Abhishek.
Actually, I am from the power plant, thermal power plant. So, because I am in the power sector, so actually I have gone through this.
Production of.
So I am not working anything, just for my knowledge and presentation purpose. I googled and made this presentation.
Okay, Abhishek. Thanks.
Thank you, sir. We are proud of Sri Gurunadha's achievement and grateful that he agreed to be our chief guest for the event. His presence and words of wisdom will undoubtedly inspire our participants and motivate them to strive for excellence in their areas. Thank you, sir. After a small tea break, the session will continue. Thank you.